Okay, so we talked about the volume being the double integral over a solid dV, but if that solid has a density, then we can talk about the mass of it. So let's look at this problem. This says find the mass of a thin, well, that's a plate. Okay. A solid never pronounced that right, trough of constant density is bounded below by the surface z is equal to 4y squared above by the plane z equals 4 and on the ends by the planes x equal 1 and x equal -1. Find the mass of the trough. Okay. Okay, so you have this trough, which is like something that holds stuff. And it is bounded above by the surface. Z is equal to 4y squared. Below by the plane z equals 4. And on the ends by the planes x equals 1 and y equals -1. Find the center, find the mass of it. Okay, I understand now. Okay, so this is what it looks like. So can you draw it? I want you to draw it before I give you the answer. So go ahead and draw it, and then I'll take a peek at your drawing. Or I'll stop sharing. I'll go ahead and let you draw it for a minute. See what you come up with.
I don't know how to draw that.
Okay. Honesty's always the best. Okay. Z is equal to y squared is a parabolic cylinder. Okay. Z is equal to y squared. In the YZ plane, I said YZ and wrote XY. In the YZ plane is this. Here's Z, here's Y. Okay, so that is Z is equal to 4y squared. The fact that it is in 3 dimensions and there's no bound on X means it's this hollow rounded that you can't see me. I need to go back on video. it's this like a parabola, but it keeps going. So it's this trough. It's a thing that keeps going. Like you would, so you would see in the YZ direction, you're going to see this thing, but it's going to keep going. Okay, do you see it now?
Yes.
Okay. All right. So that's it. It's a parabolic cylinder. All right. And it's just keeps going, just, you know, a bunch of these, and it just comes up so you can see them all. It just keeps going. Okay. So I think now you can see it. In the Y direction, because there's no, I drew that wrong. I drew that wrong. It's all together wrong. You could see it real well, but it was all together wrong. Let's try it one more time. That was wrong. This is the ZY plane. So it should have been like this. It goes this way because X can be anything. So it goes that way, goes along the X-axis. So this is the darker side. And that's the inside over here. Okay. And it cuts off between, it goes up to Z is equal to 4. So it stops at height Z is equal to 4. So when Z is equal to 4, that's where it stops. And then it's bounded between X is equal to 1 and minus 1. So here's X equal to 1. And X equal to minus 1 is over here. Okay. I am a terrible drawer.
You're not worse than me.
That is horrible. Do you even know what you're looking at?
I'm looking at, is it parabolas and
This is what you're looking at.
lines?
This is what you're looking at. That's what you're looking at. Okay.
Oh.
Okay, that's what you're looking at. Do you understand now?
Yeah.
Okay. So, but it's turned. So this is actually rotated to be along the x-axis. Because x can go forever at once. This is x. This is z. And this is y. Okay. So x goes from -1 to 1. All right. Z is going to start at the parabola and go up to z is equal to 4. And y is going to go from, well, we have to figure out where it intersects. So when z is 4 here, and z is equal to y squared, so y goes from -2 to 2. Okay, does that make sense now?
Yes.
Okay, woo, girl. All right, so therefore the mass is the integral. X goes from -1 to 1. Y goes from -2 to 2. Z goes from y squared to 4. The density is constant, dz, dy, dx. Okay, so I can pull the density out. And I'll go from -2 to 2. And then I'm going to just get z evaluated between y squared and 4 dy dx. So that's delta, the integral, -1 to 1, the integral from -2 to 2 of 4 minus y squared dy dx. Now that's an iterated integral to the point where I can do delta, the integral from -1 to 1 dx, because it has no x's in it. The integral from -2 to 2 of 4 minus y squared. Yeah, there are no X's in there. That's going to be 2. And then I'm going to get 4y minus 1/3 y cubed. Evaluate it between -2 and 2. So that's 2 times delta times 2. And well, let's skip that. I'll just do it. 2 delta. I'm going to put a 2 in there. I'm going to get an 8 minus 8/3. And I'm going to subtract off a -8 plus 8/3. 2 delta. 8 plus 8 is 16. And then 8/3 and -8/3, multiply that by 2 is -16/3. So if I factor out the 2, the delta, and the 16, I get 1 minus 1/3, which is just 2/3. 2 times 16 is 32, times 2 is 64. Okay, there we go. Okay. Oh Lord, that one gonna give you a headache. I can't give you that one. I'm telling you now, that's gonna give you a girl. Trying to protect your brain.
Thank you for that.
Okay. This one is not hard. Planes and the plane x plus, I'm sorry, 2x plus y plus 2z is equal to 6. The density solid is delta is 2x. Find the mass of the solid. Okay, this one's not hard either. Oh, that's one I just found. That's a good one. I like that one. We can do that one. That other one had like 5 planes intersecting. I was like, I can't even understand with how many planes they got here. Okay, so this is, okay. Okay, so delta's 2x. All right, so now this one has a coordinate plane over top of it, so it's very similar to the other one, but we have to find, yeah. We have to find where it meets. Okay, so when x is 0, when x and y are 0, x is equal to 3. So this is the point 3, 0, 0. And when x and z are 0, y is 6, 6, 0, 0, 6, 0. And if x and y are 0, I meant for this to be a 3 because I want z to be 2. So this is 0, 0, 2. Okay. So here's your plane on top. So this one's similar to the last one, but it's a little different. And you will see that the bottom is going to be different too. Okay. All right. So therefore we have that. Now, they tell you density. So the equation of this plane is z is equal to 6, 1/3, 6 minus 2x minus y. Okay. So that's the top. So that's where z goes from. So z is going to start at the bottom on the plane and go up until it hits the plane. So it starts on the ground. So z goes from 0 to 1/3, 6 minus 2x minus y. Okay. Then now we got to figure out where y goes from. So now we got to draw a picture. So now we have the point 3, 0. And the point 0, 6. So I need the line between there. That's actually an easy line. The slope is -2. And then the y-intercept is 6. So you get y is equal to -2x plus 6. So let's see if that works. I think it does. If x is 0, you get 6. If x is 3, you get 0. So this equation of the line. So now we get 0 less than or equal to y less than or equal to -2x plus 6. And then x goes between 0 and 3. Okay. So the mass will be integral from 0 to 3, integral from 0 to -2x plus 6. Can you see that black square?
No, I don't see no square.
Okay, good. Integral from 0 to 1/3, 6 minus 2x minus y. And then in here, I'm going to have 2x dz dy dx. Okay.
Whew.
Okay. Give you a headache. Fine. of the solid bounded above by the plane x plus y plus z equals 5, and below by the paraboloid z is equal to x squared plus y squared. Okay, so now the reason why I said, let me give you a headache, is because I haven't told you how these intersect. So all you know right now is you have a paraboloid like this. And then there's some plane cutting through it. So you're going to integrate from the surface, from here up to the plane. You're always going from the parabola up to the plane, from the parabola up to the plane. So the hard part is, what's the region down here? Okay, so let's get an idea. So we have, we clearly know that z is going to go from x squared plus y squared and z is going to go up to 5 minus x minus y. So that's the bounds on z, but we need to find the region R. So we have to set z equal. So we get x squared plus y squared has to equal 5 minus x minus y. So I get x squared. I should have made this easier. We're going to make this 2x. Okay. So then this is 5 minus 2x.
Oh yeah, I was about to say,
What?
it was a mistake, but you caught it.
Is that a mistake?
No, you wrote it already.
Oh, okay. All right, so then I get x squared minus plus 2x plus y squared minus plus 2y is equal to 5. I'm going to change this problem one more time. I'm just trying to go for easy. It's going to make that a 7. This is how you make up problems so your students don't have headaches.
Good.
You don't know until you start to make it up. Okay, so now you can see that I can add 1 and get x squared plus 2x plus 1 plus y squared plus 2y plus 1 is equal to 7 plus 2. So now I get x squared, x plus 1 squared plus y plus 1 squared, whoop, is equal to 9. Yay. So this meets, this is where it meets. So it meets at a circle of radius 3. That black. It meets in a circle of radius 3. And its center is 1, 1. It's not bad. Okay. All right, so this is x plus 1 squared plus y plus 1 squared is equal to 9. So therefore, the bottom half of this circle is, well, let's solve for y. So I'm going to get 9 minus x squared, x plus 1 squared is y squared. Right? That look good to you? I subtract, yep.
Wait,
No,
what you
y
just?
plus 1. That's
I was about to say, what you just do? What happened to the y plus
I know
1?
that's right. Y, I'm like, whoa, whoa, scary. Y plus 1 squared. Now that looks right. So square root, so y is equal to plus or minus the square root of 9 minus x plus 1 squared. Did I even give you a density?
Is it a plus 1 too? Well, subtract it.
Yes, that's what I was going to say. Then we have to subtract 1. Okay. So this bottom is, okay, so y then goes from minus 1 minus the square root of 9 minus x plus 1 squared is less than or equal to y is less than minus 1 plus the square root of 9 minus x plus 1 squared. And then x, well, let's see. If this is the center and the center is 1, 1, and the radius is 3, that means this point is 4, and I subtract 3, that means this point is -2.
Wait, wouldn't the radius be -1, or it'd be 1, 1?
Oh, no, the radius of the circle is here. Is
I
R.
meant to say, I know the radius is 3, right?
Yes.
I meant to say the center.
Oh, the center is -1. Girl, I done put the I done made the circle in the wrong place. And look, it ain't gonna let me separate. There we go. Move the circle down there. Okay, let's do this again. All y'all go away. Okay, let's try this again. The center is -1, -1. So now if I go over 3, I'm at 2. And if I go over 3, I'm at -4. Okay. So, and I kept saying -1 plus and -1 minus, never realizing that my curve was in the wrong place.
We all make mistakes.
Girl, thank you. I'm so glad some students are understanding, because some students are brutal. They are brutal. I mean, they're like, and we all have off days like everybody else. That's why I allow my students to drop an exam, because we all have off days. Okay. All right, here we go. Now, I didn't give you a density, so therefore the mass is the same as the volume. So the mass is the same as the volume. All I really cared about was you figuring out where to integrate. That's what I was most concerned about, was you getting that. So X goes from -4 to 2. Y goes from -1 minus the square root of 9 minus X plus 1 squared to -1 plus the square root of 9 minus X plus 1 squared. And then Z goes from, starts down at the paraboloid, X squared plus Y squared, and goes up to the plane, 2X plus 2Y. Stop. 2X plus 2Y no, Z minus, no. Yes, Z minus 7 minus 2X minus 2Y. There we go. All right, girlie. That's it for today.
Okay, I'll see you tomorrow.
Okay.
Have more questions. Can you do like more questions with 5.3 tomorrow?
Polar.
Yes.
Okay.
Okay, thank you.
You're welcome.
Bye-bye.